Fossils and Rock Layers, A Window into the Past by Lydia Rodriguez. To find the order in which the rock layers were formed in, I use the law of superposition. The law of superposition states that if any rock layers are undisturbed, the rock layer that lies at the bottom will be the oldest rock layer, while the rock layer that lies at the top will be the youngest rock layer. According to the law of superposition, the rock layer that formed first was rock layer W because it lies at the bottom. The rock layer that formed second is rock layer V. The rock layer that formed third is rock layer U. The rock layer that formed after rock layer U is letter T. Then rock layer S formed. After rock layer S formed, rock layer R formed. And then after rock layer R, Q formed. Last but not least, the last piece of rock that formed was the igneous intrusion labeled letter X. I know that the igneous intrusion labeled letter X was formed last because of the law of cross-cutting relationships. The law of cross-cutting relationships says that if an intrusion, in this case an igneous intrusion, that passes through rock layers, the rock layers that it passes through will be older than the intrusion itself. Since the igneous intrusion passed through all the layers, the igneous intrusion will be younger than the rest of the rock layers. I know that letter X is an igneous intrusion because igneous rocks are usually formed when lava or magma cools and hardens. This igneous intrusion, however, is made from magma. I know this because magma forms from under the earth. The rest of the rock layers are formed from sedimentary rock. I know this because sedimentary rock is the only rock that can contain fossils, because when the sediment forms around the fossil, it helps to preserve the animal's parts better. Our first index fossil we find in rock layers M and U. The index fossil we find in these layers is called the Dichordium, which is a seed fern, but in this case, it looks like a black fern. Our next index fossil we find in rock layers N and V. The index fossil we find in these layers is called the Eleuthopteris, which is a fern, but in this case, it looks like a feather. Our last index fossil we find in rock layers O and W. The index fossil we find in these layers is called the trilobite. You might ask, how do you know that these fossils are index fossils? Well, to be an index fossil, the fossil must be widely distributed and briefly existing, which means that the fossils have to be in many different locations, and the species in which they are have to have only lived for a short period of time. To be widely distributed, the fossil has to be found in only one layer at many different sites. These three fossils are known as index fossils because they are all in different locations, or in this case, they are both at Site 1 and Site 2. So they are widely distributed, and they are only found in one layer at each site, so they are also briefly existing. These fossils all have the requirements to be an index fossil, meaning, as I say again, they are both widely distributed and briefly existing. So this proves that they are index fossils. Index fossils are important because they help us, meaning geologists, to find the relative ages of other rocks around them and the relative age of the rock layer the index fossil lies in. An example of this may be if a fossil is 200 million years old, and it is widely distributed and briefly existing, it will be an index fossil. And since an index fossil helps us to find the relative age of other fossils in the rock layer the index fossil lies in, the relative age of the rock layer the index fossil is in would be about 200 million years old. In this slide, I'm going to tell you how the environment in the Grand Canyon has changed over many years. In the first rock layer W, the environment these fossils lived in was the ocean, mainly on the ocean floor. I know this because a fossil in this rock layer is coral. And today, we know coral lives at the bottom of oceans. Now, as we move on to the next few layers, we can see that the fossils no longer live in an environment that contains water, such as an ocean. But these fossils lived on land, mainly in a hot, dry, desert-like climate, and some could even live in a cold, icy environment. I might as well say that their environment fluctuates between hot weather and cold weather. Right now, between these three rock layers, the environment has started to change from an ocean climate to where animals cannot survive the cold to an environment that now affects animals on land by fluctuating between hot and cold climates. For our last few rock layers at this site in the Grand Canyon, the environment is almost the same as the first few rock layers in this site. In the next two rock layers, we have the same three fossils that lie in each layer: coral, the crinoid, and brachiopods. These three fossils used to have lived at the bottom of oceans or shallow seas, and many of these animals also could never survive cold temperatures. Our last layer that appears in this site contains an Arizonosaurus fossil. This fossil is from the Mesozoic era during the mid-Triassic period, which was when dinosaurs roamed the earth. This dinosaur lived in a hot, dry, desert-like climate environment. Overall, the environment has changed in many ways. First, the environment started out in water, but eventually made its way to land, where the climate changed from hot, dry, desert-like climates to very icy, cold climates. As you might have noticed, the environment has changed upon which period it was in. As the periods went by, the environment started to change into the environment we have today.